Yes, good evening. In continuation to last page of concrete specifications by me. This is my certification. And see yourself. No need for explanation. We talked of section 5 concrete. We talked of last time general. In introduction, aggregate, etc. And up to 41 pages were taught. This is available in last video, that is already discussed, so I'm not going to repeat that, save time. It's not going to repeat it today. I'm just going to save time for that. No need of free information. You can see last video if you have interest to know that what I explained. Page 13, 14 and all that went through yesterday or before yesterday, I think, whatever day it's in record. So I'm just browsing it so that you can remember. No need of explaining again and again. It is self-reading, self-reliable. You can read yourself or engineers. I'll just move. I will talk of water and very specific quality of water we talked of, pH, etc. We talked of, and then we talked of all that. Admixture, talked of admixtures at length. We talked of various issues, properties and all properties we discussed at length. A long list of codes, American codes, British codes, European codes. And then we talked of classes, and then we talked of continuous bodies, and now page 40 we talked of, then 41 also we talked of. Now we talk of exposure classes, this is 41, and before that let us overlap this page 41 and 40 better. We overlap this page so that We know a little more in that. So we defined GJBS, etc., all that. No need of doing. So we start from here. Submit complete mix design data for each separate mix to be used on project in a single submittal with at least following information: type of cement, potent cement content, cementitious content, GGBS, FA, natural pozzolana risk, rice husk and or silica fume, maximum aggregate size, combined grading curve for coarse aggregate, quantities of all individual materials, type of admixtures, target slump flow at discharge, initial and final concrete setting time for each mix design for each. Okay, now according to STM C402R equivalent BSEN standards, if specified fresh density of concrete per BSEN 123506, air content per BSEN 123507, target temperature, bleeding if specified, chloride and sulfate, SO3 contents, details of calculated water per cementitious materials, that's called water cement ratio, and compressive strength, grade, hardened density, water absorption percentage and water penetration, if specified, rapid chloride permeability, column values specified. This is very, very important. It should not be 2500, be below that it should be. That's general rule. Chloride migration effect of coefficient m square per second if specified, and that is include on delivery ticket as a minimum. Data shall be from same production facility that used for project. Design data shall include but not be limited to following: location on project where each mix design is to be used, corresponding to structural general notes on drawings. Structural general notes on drawing, this is a must. It's very useful, very supportive to working people, executive people. Proportions: concrete constituent materials shall be proportioned to yield 1 meter cube. Concrete constituent material shall be proportioned to yield 1 meter cube. 1 meter cube means wet. Wet means pourable quantity 1 meter cube. Submit strength test records, mix design, materials, conditions and proportions for concrete use for record of tests, standard deviation calculation and determination of required average compressive strength if demanded by engineer. If early concrete strength is required, contractor shall submit trial mix result as required. Test records to support proposed mixture shall be no more than 12 months old and use current cement and aggregate sources. Test records to establish the standard deviation may be older if necessary to have required number of samples. Manufacturer's product data for each type of mixture. Manufacturer certification that all admixtures used are compatible with each other. All information indicating compliance with contract documents include method of placement and method of curing. All I'm telling is then because the contract requires all these details, project requires these details, a part of contract document specifications which require all such details could be project specification or could be general specification, particularly project specifications value more, way more. So that's why I'm saying it's also a part of contract. It's not exclusively technical with contract basis. So we should say it's very important. Then we can move on to massive concrete. Submit mix design for massive concrete element in conformance with requirements of ACI 301 Section 8. Concrete mix design shall not be done with a higher strength unless otherwise demonstrated by contractor for capability of maintaining proper temperature and approved by engineer. Proper temperature maintenance is very important in case of thick elements and massive blocks. temperature, which impacts on durability of concrete because of structural integrity within its mass of concrete. You can say like atomic structure it is. So we can say temperature values a lot, which we should understand. All temperature from mixing to hardened state during curing itself. That's very important point which we lack a little to understand. And it's very important to know that temperature applies on mixing and it applies on laying, and it applies, laying means pouring, and it applies during initial setting as well as it applies during hardening stage, during curing, and during every activity of concrete. It's very important to understand. Submit proposed methods of temperature control, including cementitious material control, cementitious material central content control mix designed to reduce heat generating potential of concrete. You mean you have to reduce heat generation, you have to initial heat generation potential of concrete, pre-cooling of ingredients to lower concrete temperature as placed, and methods to protect mass concrete element from excessive temperature differentials. Submit analysis of anticipated thermal development within mass concrete elements with proposed mix design for these elements. Results of analysis using methods in ACI 207 1R and ACI 207 2R, such as schematics model and site specific data, shall address minimum differential temperature, and maximum temperature during curing. So this is some reading problem sometimes. Submit analysis of anticipated thermal development within mass concrete element, and with proposed mix design for these elements. Result of analysis using method ACI 2071R, ACI 2072R, and schematics model and site specific data shall address maximum differential temperature and maximum temperature during curing. Submit proposed number and locations of temperature monitoring devices to record temperature development between interior and exterior of mass concrete elements. This is very important point. Submit proposed number and locations of temperature monitoring device to record temperature development between interior and exterior of concrete element. Exposure classes. General. Exposure classes are related to environmental conditions surrounding concrete in service. Concrete may be subject to more than one of classes described herein, and environmental conditions to which it is subject need be expressed as combination of exposure classes. Where two or more aggressive characteristics lead to same class, exposure shall be classified into next higher class unless a special study for this specific case proves that it is not necessary. For a given structure, different concrete elements may be subject to different environmental classes. Now, reinforcement, corrosion, and sulfate classes. Classification system described herein is based on approach to BSEN 206-1, BS 8500-1, and Concrete Society CS 163. Exposure classes related to reinforcement, corrosion are associated with carbonation and chloride per table 6.1. Exposure classes related to sulfate attack in given table are given in table 6.2 in relation to sulfate and pH of groundwater. Sulfate contents as SO4 mg milligram per liter shall be determined per BSE in 1962. pH shall be determined per ISO 4316. Class table 6.1 exposure classes for reinforced corrosion. Here's a column exposure class and then class description. Now it's X0, X1, X2, X3, X4, X5, X5, and then let us see what it is. X0 or X0, no risk of corrosion as we discussed before or attack. Non-saline conditions, binding concrete. Blinding concrete means blinding is concrete below foundation, which does not have any structural requirement, just removing unevenness of formation level. That's called blinding concrete, and in our country, Bharat, India, we call it lean concrete. It's same thing, but blinding concrete means no need of lime, just cement concrete M15 or M20. It is in many cases up to M20 or 25 also in some cases. It depends. Non-reinforced concrete or slab or in ground. That's all. X0. Now X1. X1, that's mild exposure, known saline conditions, dry or wet, rarely dry. External concrete at least 3 meter above ground level, 3 meter above ground level. Internal concrete in dry conditions, concrete permanently submerged in non-saline water or non-aggressive groundwater, class S1. X2, I already discussed in just reading table because table I feel that way. X2 is moderate exposure, non-saline conditions such wet and dry cyclic wet and dry. External reinforced concrete less than 3 meter above ground level. Water retaining structures are exposed to fluctuating water level. X3, that is aggressive exposure. Aggressive exposure starts something permanently submerged wet, rarely dry. Concrete in contact with groundwater, including capillary rise zone, concrete containing or permanently exposed to saline water. X4 is severe exposure, which is also upgraded from aggressive to severe exposure. Moderate humidity, external concrete within 1 kilometer from sea or in contact with high saline water, table or subcars. Concrete not affected by condensation, irrigation or leakage, which are more than 3 meter above ground level. X5, extreme exposure, cyclic wet and dry, external concrete within 1 kilometer from sea or in contact with high saline groundwater or subcars. Concrete affected by condensation, irrigation or leakage, which are less than 3 meter above ground level or within capillary zone. Concrete surfaces exposed to seawater splash or in seawater tidal zone, which is X5 most critical. Now table 6 to sulfate exposure class. Here we have S1, S2, S3, S4, S5. And this sulfation magnesium 2:1 water soil or groundwater. Water soil or groundwater. Then natural soil and brownfield. In natural soil static water pH, mobile water pH. In brownfield static water pH and mobile water pH. Now SO4 milligram per liter, that is under 2:1 water soil or groundwater equal water soil, and mg milligram per liter. So let us see S1, which is S1 is less than 1500 milligram per liter. Static water pH is in natural soil greater than 3.5, not mobile. Static water pH is greater than 5.5. Mobile water pH is not mobile. S2 1500 to 3000, that is SO4 2:1 water soil, 1500 to 3000. Static water pH is greater than 3.5, not mobile, and greater than 5.5, not mobile. Some phone is ringing, I can't stop because I can't move. I mean bad. Sorry for that. Somebody has kept that my assistant, medical assistant. He is not available at the moment. Well, S3 3001 to 6000 and milligram is less than 1000. Static water pH is greater than 3.5. Mobile water pH is not mobile. Static water pH is greater than 5.5 and not mobile. Now let's say S3, that is 3001 to 6000, and I think I've gone through this. Now say S4, greater than 6000 and greater than 1000, sorry, less than equal to 1000, I'm sorry, then greater than 3.5 and greater than 5.5, that's mobile water. Static water is greater than 3.5 and static water pH is greater than 5.5. Mobile water pH is greater than 6.5. That's for brownfield, and that's S5. That is S4 or 5. Let's say I think it was 5. No. So greater than 6000, that is SO4, less than equal to mg, less than equal to 1000 mg per liter. Static water pH is greater than 3.5. Mobile water pH is greater than 5.5. Static water pH is greater than 5.5. Mobile water pH is greater than 6.5. S5 greater than 6000 and mg is greater than 1000. That's milligram per liter. Static water pH is greater than 3.5. Mobile water pH is greater than 5.5. Static water pH is greater than 5.5. Mobile water pH in brownfield is greater than 6.5. The sulfate exposure classes. Now, brownfield sites are those previously occupied and contain chemical residues into ground or groundwater. So, the explanation of that, brownfield sites are those previously occupied and contain chemical residues into ground or groundwater. Mobility of water shall be determined as described in Concrete Society CS163. Now fresh concrete we are talking. Fresh concrete. Fresh concrete we are talking. Fresh concrete. And then we say, what is fresh concrete? Where adequate workability is difficult to obtain at maximum water cementitious ratio, allowed use of plasticizers or water reducing admixtures may be considered. Alternatively, an increase in cementitious content may be considered where this will not adversely affect durability of concrete. Repeat, where adequate workability is difficult to obtain at maximum water cementitious ratio, allowed use of plasticizer or water reducing admixtures or plasticizers may be considered. Alternatively, an increase in cementitious content may be considered where this will not adversely affect durability of concrete. Cementitious contents in excess of 400 kg per meter cube shall not be used unless special consideration has been given to effect for heat of hydration and reduce thermal stresses in concrete. An approval has been obtained from engineer also. Maximum cementitious content shall not exceed 500 kg per meter in whatever case. Proportioning, mixing and placing of mixture shall be in accordance with Part 7 and Part 8 of this specification. Temperature at placement. Temperature at placement is very important from quality viewpoint, which we people miss in here. It's very important point, and it was used in 80s in Gulf countries. I controlled their temperature even in 1986. Maximum fresh concrete temperature shall not exceed 32 degrees Celsius maximum, unless construction testing to verify a proposed concrete mixture shall function satisfactorily at a concrete temperature greater than 32 degrees Celsius No concrete shall be placed if concrete temperature is above 35 degrees Celsius. No concrete shall be placed if concrete temperature is above 35 degrees Celsius. Keep in mind 32 is maximum. In rare circumstances, you may go up to 35 degrees Celsius. For massive concrete, this mass actually is misnomer. Actually, it's called massive concrete. In massive concrete, concrete temperatures, concrete producers shall demonstrate. I mean to say, concrete ready mix plant shall demonstrate that temperature of concrete due to hydration shall comply with maximum fresh concrete temperature specified as above. Supplier may use in his demonstration testing heat sensors. Supplier may use in demonstration testing heat sensors and simulation technologies which measure concrete heat of hydration and its rate versus concrete curing age. Curing age. Contractor is responsible for ensuring that concrete is able to be fully compacted within concrete element regardless of reinforcing density or other limitations. This may involve reducing maximum aggregate size, increase level of concrete workability, or use self compacting concrete. Where consistence of concrete is to be determined, consistence of concrete is to be determined, it shall be measured either by means of slump test conforming to BSEN 12350-2 or flow table test conforming to BSEN 123505. Consistence of concrete shall be determined at time of use of concrete or in case of ready-mix concrete at time of delivery. Consistence of concrete shall be determined at time of use of concrete or in case of ready-mix concrete at time of delivery. Tolerances for different consistence tests and target values are here in this table 6.3. Tolerance for target values of consistence slump is target value less than equal to 40 and that is 50 to 90 greater than 100. This is point here tolerance values depends on what? Then minus 30 plus 40 tolerance, and in this case minus 40 plus 50 tolerance, greater than 100 minus 50 plus 60 tolerance. This is in this case target value. This is tolerance. So less than equal to 40 means this is tolerance given here. That is in slump, whereas flow diameter is target values, all values. Tolerance is minus 60 plus 70 or spot samples taken from initial discharge. Grades of concrete, where strength is classified with respect to compressor strength. Table 6.4 herein gives concrete grade with requirements for water cement ratio and cementitious content. Characteristic compressor strength at 28 days of 150 cubes, that is FCK cube, or 150 diameter by 300 cylinders. FCK CY cylinder CYL is cube. The cylinder may be used for classification. Exception be made for concrete mixture containing fly ash, silica fumes, or GGBS, where testing be requested for 56 days or 90 days for approval by engineer, because these are low heat cements. It takes time for final job. So concrete grades and composition requirements are concrete grade, then minimum characteristic cube strength FCK cube, Newton per millimeter square, minimum characteristic cylinder strength, that is FCK CYL, Newton per millimeter square, minimum cementitious content kilogram per meter cube, maximum water cement ratio. Now let us see what does it say. B15, that is 15 Newton per meter square minimum characteristic cube, strength, and minimum characteristic render strength is 12. That's normal, and B20 is 2016, and B25 2520, and then minimum cementitious content is 60, and water cement ratio is 0.6. C30, this is 30, 25, 25 in case of cylinder strength, 260, that is minimum cementitious content, and this is 300 kilogram per meter cube, then 0.58 water cement ratio. So as we upgrade, we find water cement ratio is reduced. You can see very well. Now see 35, 28, 320, 0.55. Cement is increased, but water cement ratio is decreased. C40, 32, 335 kilogram per meter cube, but 0.5 water cement ratio. C45, 35, 355 means increase of 20 kilogram per meter cube and 0.47 water cement ratio. C50, 40, 370 again increase and 0.45. And C60, 50, 380 and 0.4, and C75, 60, 390 here. It doesn't cross 400 even case of C75. So you can say here even C30 is 300, then 35 is 320 kilogram per meter cube of cement materials, and C43, 35, C45, 355, C50, 370, C60, 380, C75, 390. So here 0.35 in case of this. Even C40 is 0.5 maximum. So you know that. And C25 is 0.6. So it says 0.6 to 0.35 is a drop of 0.25 water cement ratio. This is point very understandable. Now durability requirement is also very important. Durability requirement, you have to understand that constituent material shall not contain harmful ingredients. Whatever material we use shall not contain any harmful ingredients in such quantities as may be detrimental to durability of concrete or cause corrosion of reinforcement. For reinforcement concrete in ground, need for protection from chlorides must be balanced against need for protection from sulfates. Protective measures include use of surface treatment, alternative reinforcement, and increasing concrete cover. In every case, need for good quality concrete with low permeability is paramount. So, what you say? Use of surface treatment. Whatever foundation we lay, it should be protected from negative impact or adverse impact of chlorides and sulfates from soil and also from water-soil solution, which carry with it very fine particles and chemicals. So there should be proper surface treatment, that may be called waterproofing in your trade language. Or it is concrete surface protection from soil and from chemicals, and which also should be further protected so that your water protection membrane remains intact. Or alternative reinforcement and increasing concrete cover. Well, a concrete cover is always be never less than 50 to 60 mm in case of foundations. And alternate reinforcement, well, this is in every case need for good quality concrete or with low permeability is paramount. Low permeability means high density concrete. Low permeability is very important. Now maximum acid soluble chloride contents. Chloride content of concrete expressed as percentage of chloride ions by mass of cementitious material shall not exceed value given in table 6.5. Let's see what is that. Calcium chloride and chloride based admixtures shall not be used in concrete containing steel reinforcement or other embedded matter. Determination of chloride content in concrete shall be conducted by sum of contributions from constituent materials described for description in BS EN2061 and BS85002. Now table 6.5, this is maximum chloride content of concrete by weight of cementitious materials. Type of concrete, RCC and pre-stress concrete. Concrete made with sulfate resisting Portland cement, sulfate resisting Portland cement, 0.15% in reinforced concrete and 0.08% in pre-stressed concrete. Concrete made with other cementitious materials, then SRPC, 0.3% and 0.1%. Types of cementitious materials. Now important point is coming, is very very important from every aspect. We have to understand that. It's not simple. Okay, let's move. Type of cementitious materials. So different types of cementitious materials offer different resistance to sulfate attack and sulfate attack and penetration of chlorides. Different types of cementitious materials offer different resistance to sulfate attack and penetration of chlorides. Minimum cementitious content for different concrete grades, which is here in 6.4 is already given. Now table 6.6 gives different types of cementitious materials and their combinations. Cementitious materials and combinations, column cementitious material and percentage of components, then BSEN 197-1 designation, ASTM standard. Portland cement is 100% PC, that is CAM1 type 1, and then percentage of components, then because it is Portland cement 100%. Sulfate resistant Portland cement is 100% SRPC and that's type 5 ASTM standard. Now PC fly ash, which is now actually supplementary cementing material, starts at PC, that is plain concrete fly ash, and 65 to 79% PC and 35 to 21% fly ash. So there can be 65 and 35, 65 replacement of cement by fly ash. So 65 plus 35 becomes let us say it's 35% replacement. I'm sorry, 65 is Portland cement and 35 is fly ash. So 35% replacement of cement OPC by fly ash, or to 79% PC. You can say PC is 79 is cement, OPC is 79 by 21 is fly ash. So here 21% to 35% fly ash replacement of Portland cement. This is according to CEM second BV, that is BSEN 197-1 designation. Now move on to PC, ground granulated blast furnace, which is much more useful than this. Portland cement ground granulated blast furnaces slag, in which case if you are using only 35 to 65% PC, means you are using Portland cement 35 to 65%. If you use 35%, 65%, you can say GGBS can be added. Means Portland cement to an extent of 65% can be replaced by GGBS, and if you use 65% Portland cement, then 35% GGB replacement can be done to Portland cement. This is CEM3 A. Better is that use ground blender GGBS, because GGBS can be ground to whatever fineness value, while fly ash cannot be done. That there's a limit in fly ash. But when you use GGBS, it is much more finer than that, and it can be controlled during grinding and can give you more marvelous. So you can replace even up to 70%. I have used this 70% replacement concrete for massive block of cracked gas compressor foundation, which is up to 500 cubic meter, for which we did thermal curing. So triple band PC, now we are going to use 3 items: PC, fly ash and SF. So we can say, let us say PC is 55 to 70%, that's plain cement, OPC, Portland cement, and fly ash is 35 to 25% and 10 to 5 is SF. Now silica fume, SF is silica fume, it's not written here, but it is micro silica fumes. So here what we do, 55% we say cement, Portland cement, 35% fly ash, and 10% silica fumes. So it is 55 plus 35 plus 10, 100, or use 70% Portland cement, 25% fly ash, and 5% silica fumes. So 70 plus 25, 95, and 5 is 100. Triple blend, that is PC, GGBS, and SF. So previous case was for triple blend using SF and PC and fly ash. In this case, we are going to replace fly ash by GGBS. So 30 to 45% Portland cement, 60 to 50% GGBS, 10 to 5% silica fumes or micro silica. 30 plus 60 plus 10 is 100, 45, 50, and 5 are 100. So here GGBS is 60 to 50% and silica fumes is 10 to 5%. So total replacement of Portland cement is by 70%, while in previous case it was only 45%. Here we are having better management, better production of low heat cement, low shrinkage cemented material. We have to understand this point. Now resistance to alkali silica reaction is also very important point. Resistant to alkali silica reaction. Resistance to alkali silica reaction. Alkali silica reaction is most common form of alkali aggregate reaction. Alkali silica reaction is more common form of alkali aggregate reaction. Dry concrete is not prone to cracking by alkali silica reaction, as it needs an external source of water to develop sufficiently to cause cracking. Where aggregate contains variety of silica susceptible to attack, where aggregate contains variety of silica susceptible to attack by alkalis from cement and other sources, and concrete is exposed to humid conditions. Humid conditions, remember, action shall be taken to prevent deleterious alkali silica reaction using recommendations and procedures given in British Standards EN 2061 and BS 85002. Recommendations to resist reinforcement corrosion. How to resist reinforcement corrosion? Durability design should start at concept design stage. Concept design stage, you understand what does it mean? When you think of how to design concrete, continuing through design, detailing, specifications, and execution is this. Remember, this is very important. Design, detailing, specification, and execution phases. All three are clubbed in this specifications. Design has been pulled in for purpose of durability. Specifications do exist there, without which work can't be done, and execution phase, which is a real implementation on site. This section covers concrete grade cementitious type and minimum concrete cover for various exposure classes as given previously in 6.1. Now this table provided 6.7 provided recommended values of concrete grade and cover thickness to resist reinforcement corrosion at different exposure classes. This is table 6.7, recommended durability requirement to resist reinforcement corrosion. Exposure class same as X0 or X0 to X5, and what says where corrosion applies, where doesn't apply, and minimum concrete cover is given here in cement this type, which one is the In case of 0x0, there is no risk of corrosion. So cover is 25. Okay, no problem. Cementitious type all. Then X1 mild corrosion. Cover is 45, 40, 35 for 30 and all cementitious type. So let's go further here. Then X2, which is moderate corrosion. So 50 in place of 40, 30, 45 in place of 35, 40 in place of 30, and 35 here in all concrete. So here in moderate case we have added 10, 10 and 10 and 35 here. Then aggressive case comes where 70 in this case 70, 65, 60, 55 where there is a triple blend of PC, FA, PC, GGBS triple band. A severe condition is further 75, 70, 65, 60, PCFA, PCGGBS and triple band. And then extreme is 80, 75, 70 and 65 triple band, and minimum concrete grade is C30, 40, 65 and 50, 60 and 75. These are grades and these are covers about these grades. So C30 is not a big problem in this case except in mild, and that then in C30 these cannot apply. Moderate, aggressive, severe and this moderate, aggressive, severe and extreme in C30. In C40 minimum we have to C40 in case it's moderate, aggressive, severe and extreme, and if it is for C50 then it's all this, and in this case you can read yourself. High level of cement replacement is required for severe and extreme exposure conditions. Other protection measures such as coated reinforcement or surface treatment may be considered. These two I already discussed with explanation. So notice here, high level of cement replacement is required, which means 70% replacement, and in some cases even 80% replacement may be done. So if you want high level of cement replacement by GGBS plus microsilica required for severe and extreme exposure conditions of concrete, and other measures such as coated reinforcement or epoxy coated reinforcement or surface treatment may be considered. Now recommendation to resist sulfate attacks. Exposure classification shall be identified based on sulfate and magnesium contents in ground and groundwater, pH and mobility of groundwater as given table. Mobility of groundwater is very important. Exposure classification shall be identified on sulfate and magnesium contents in ground and groundwater, pH and mobility of groundwater as given in table 6.2. Now recommended concrete specification requirements in terms of concrete grade and cementitious types are given here in 6.8 table. Unless stated otherwise by engineer or project design, all concrete below ground shall have surface protection to prevent movement of moisture from ground through foundations into superstructure. Method of protection shall be in accordance with section 15 of QCS or as approved by standards. Now this is table 6.8. Recommended durability requirement to resist sulfate attack. Exposure class, minimum concrete grade and cementitious type. S1 to S5 we have. In S1 C35, not less than that, all cementitious type. S2 C40, C50. In case of C40, triple blind. In case C40, SRPC, PCFA, PCGGBS. S3 is C50, C60, triple blind, and SRPC, etc. Combination of all. And then S4 C60, C75, triple blind, and S5 C note. Note is, what is note? S5 requires spatial treatment when sulfate content exceeds 6,000 milligram per liter sulfate content exceeds 6000 milligram per liter and magnesium content exceeds 1000 milligram per liter. This is S5. Durability related properties. Durability related properties. We have to see that. Durability of concrete is greatly influenced by ability of concrete cover to resist the movement of liquid and gas through concrete. What is that? Durability of concrete is greatly influenced by ability of concrete cover. Ability of concrete cover to resist movement of liquid and gas through concrete. We have to resist movement of liquid, that is water, and gas through concrete. Commonly used tests for assessing transport properties of concrete are listed in 6.9 table together with typical values. A lower value indicates more durable concrete. Okay. No values are currently specified for various exposure classes but may be requested by engineer. Table 6.9 gives recommended durability relative properties and typical values for development of mixed design and comparative performance as given in Concrete Society CS 163. For severe and extreme exposures, it's recommended to use high durable concrete. Table 6.9. Now this is durable concrete. Recommended properties and typical values for concrete. Concrete property test method, age range between 28 and 90 days. High durability, minimum durability. Now let us see. Water absorption, BS 1881, part 1 to 2. High durability is 2%. Water absorption should not be more than 2%. Minimum durability, it can be up to 4%. Water penetration, BSEN 123908. High durability 5 mm and minimum durability 30 mm. So 5 mm and 30 mm you can see. 5 mm is better or 30 mm is better. You can understand yourself. Means if it is 5 mm means it is less permeable while penetrable, and when it's 30 mm it's not durable. Rapid chloride permeability RCP ASTMC 1202 500 columns in case of high durability and 4000 columns in case of low durability. Generally, I think from 500 to 1500 and then say up to 2500. In case of very good concrete, 500 is okay, but for moderate buildings, it could be even up to 1500 to more than that sometimes. Chloride migration, that's anti-build 492, that is 2.0 into 10 to power minus 12 meters square per second. Chloride, quantity of chloride migration. Previous was unit, that was column, electrical unit. And this is chloride migration, that is 2 into 10 to power minus 12 meters square per second. In negative power, remember it's not positive power. And for minimum durability, it is 9 into 10 to the power minus 12 meters square per second. That is about 4.5 times, and so it is less than that. Concrete shall be tested for some of transport properties when requested by engineer and shall be tested at 28 days. Exception be made for concrete mixtures containing fly ash, silica fumes or GGBS layer. Testing shall be requested at 56 days or 90 days. Design of concrete mixes. Design of concrete mixes. Design of concrete mixes. At the start of construction period, contractor shall design a mix for each grade of concrete. Each mix design shall be such that aggregate shall comprise fine aggregate and coarse aggregate with size specified in section 5 part 2. Means this page. Combined aggregate grading shall be continuous. Aggregate quantity shall be calculated by weight, not by volume. Where a concrete production facility has a strength test records not more than 12 months old, a sample standard deviation SS shall be established. Test records from which SS is calculated shall consist of at least 30 consecutive tests or two groups of consecutive tests totaling at least 30 tests. Where a concrete production facility does not have strength test records meeting requirements of 6.63 above, but thus have test records not more than 12 months old based on 15 to 29 consecutive tests, a sample standard deviation SS shall be established as product of calculated sample standard deviation and modification factor of table 610. Now modification factor for sample standard deviation when less than 30 tests are available. Number of tests and modification factor for sample standard deviation. Less than 15 tests, use para 7 below. Para 7 below which says, we'll see, okay. Now, less than 15 is para 15. Then it is number of tests 15, 1.16, and number of this is tests of 20, 1.08, 25, 1.03, 31. Interpolate for intermediate number of tests. Modified sample standard deviation SS to be used to determine required average strength F-CR. Now property requirements. To determine correction factor between cube strength and cylinder strength, contractor shall establish at least 30 consecutive strength tests from each proposed mix design. This correction shall remain valid through project providing that no change in properties of materials and no change in source occur. Required average compressive strength, target mean strength, F-CR used as basis for selection of concrete proportions shall be determined from table down 611 using sample standard deviation SS. Required target mean strength when data are available. To establish a sample standard deviation, specified compressive strength Newton per millimeter square or MPa, that is megapascal, and required average compressive strength target mean strength Newton per millimeter square or MPa. F-C is less than equal to 35 MPa, see footnote, and this is here equation 1 and 2. F-CR equal to F-C plus 1.34 SS or F-CR is equal to F-C plus 2.33 SS minus 3.5 equation 2. F-C is greater than 35 MPa, see for footnote. F-CR equal to F-C plus 1.34 SS is equation 1 above, and F-CR is equal to 0.9 F-C plus 2.33 SS equation 3. Use large value computed from whatever equation. Large value. When a concrete production facility does not have field strength test records for calculation of SS, required average strength, target mean strength F-CR shall be determined as follows. A. F-CR equal to F-C plus 8.5 MPa when quantity is less than F-C is less than equal to 35 MPa. B. F-CR equal to 1.1 F-C plus 5 MPa and F-C is greater than 35 MPa. Concrete. Portland cement concrete shall consist of mixture of cementitious materials fine aggregate, coarse aggregate, water and additives when required. It shall be classified as given in Table 6.4 unless otherwise stated hereinafter and requested by engineer. Blinding concrete. Blinding concrete shall be minimum grade C15 and above. Thickness of blinding concrete shall be as shown on drawings but shall in no case be less than 75 mm. Surface finish to blinding concrete shall be class U4 as specified in clause 931 part 9 of this section or as directed by engineer. Mass concrete or massive concrete. Fresh concrete temperature. Let me hold on just a minute please. It pass out my mass concrete. Fresh concrete temperature at a mass concrete means massive concrete. Don't be confused with blinding concrete or fill concrete. This is not fill concrete but massive concrete, block concrete. Big block more than 8 cubic meter to whatever number. The temperature is under control. Fresh concrete temperature at placing shall not exceed 21 degrees Celsius. 21 degree Celsius. To minimize thermal cracking means we have to minimize thermal cracking. A higher temperature of up to 27 degrees Celsius may be accepted with a demonstration of satisfactory performance of concrete including mock-up means test, site test, and thermal calculations. Maximum allowable differential temperature between interior and exterior of mass concrete element shall not exceed 20 degrees Celsius. This is very important, mind it. These temperatures are very important for very heavy foundations or very heavy structures. 21 degrees Celsius minimum for thermal control. Fresh concrete temperature at placing shall not exceed 21 degrees but can be up to 27 degrees. Generally 24 degrees is practically acceptable in good weather condition. Okay, 27 can be accepted with demonstration of satisfactory performance of concrete including mock-up and thermal calculations, and maximum allowable differential temperature between interior and exterior of massive concrete element shall not exceed 20 degrees Celsius. This is very important point which you have to understand. Means internal concrete temperature during casting and hardening and surface temperature, there should not be difference more than 20 degrees Celsius. This means you need complete total control, continuous control. This is a very important point we have to understand. Maximum temperature in any location, whatever location within massive concrete structure during concrete shall not exceed 70 degrees Celsius. What it says, maximum temperature in any whatever location within massive concrete structure during curing, mind it, shall not exceed 70 degrees Celsius. Drop in concrete surface temperature. Drop in concrete surface temperature during and at conclusion of specified curing period shall not exceed 11 degrees in whatever 24-hour period. So there is a variation of 70 degrees to 11 degrees when curing period ends. During curing period, at maximum temperature in whatever location within massive concrete structure during curing shall not exceed 70 degrees Celsius, and at conclusion of curing shall not exceed 11 degrees Celsius in 24 hours period. Mind it, it is 24 hours period, not in 1 hour. Because of fluctuation in weather conditions, fluctuations, humidity levels and everyone, so variation is During during curing and start curing, 70 degrees in 24 hours to 11 degrees Celsius and self-compacting concrete. Self-compacting concrete (SCC) is a special concrete that requires minimum or no vibration for placing and compaction. It's able to flow under its own weight, completely filling formwork and achieving full compaction, even in presence of congested reinforcement. Hardened concrete is dense, homogeneous and has same enduring properties and durability as traditional vibrated, fully compacted concrete. Self-compacting concrete supplier. Concrete (SCC) shall be supplied by a competent concrete producer with a record of successfully producing this type of concrete at considerable volume and with high consistency. Constituent materials general. Constituent materials for SCC are same as those used in traditional concrete conforming to EN 2061 as specified in part 2 of this section. To achieve these requirements, control of constituent materials needs to be increased and tolerable variations restricted so that daily production of SCC, that is self-compacting concrete, is within conformity criteria without need test and or adjust every batch. Recommended test requirements of SCC, laboratory test and field test. Slump flow, V funnel, L box, J ring. In slump flow, laboratory test 600 to 750 mm, field test 550 to 750 mm. V funnel 6 to 25 seconds in laboratory and not applicable in field. L box is greater than equal to 0.8 in laboratory and not applicable in field test. J ring less than equal to, previous L box was greater than equal to, not less than, the 0.8 greater than equal to and not applicable in field test. While J ring is less than equal to 10 mm and not applicable in field test. Concrete specimen shall be molded in single layer without rodding and tapping. Slump flow and VSI testing shall be performed as outlined in European guidelines. For SCC, BSEN 12350-8 and BSEN 12350-9, RACI 237R 07 and ASTM-C 1611/C 1611M. Pile concrete. Pile concrete cementitious content shall not be less than 380 kg per meter cube. Water cementitious ratio shall not exceed 0.45. So for piling, so 380 kg per meter cube, this is maximum cementitious content, and water cementitious ratio is maximum 0.45. Concrete mixture shall be designed of high slump not less than 150 mm, allowing proper free fall with excellent homogeneity. When concrete mixture requires slump of greater than 230 mm, it shall be designed as self-compacting concrete or as instructed by engineer in charge. Concrete slump shall have adequate workability, retention using approved type of retarder, and shall be submitted in design mix. Concrete slump shall have adequate workability, retention using approved type of retarder. Increase in workability shall not permit any decrease in specified design strength. Concrete in a pile shall, if at all possible, be placed in one continuous operation continuous flight, CFS we call it. Underwater concrete. Underwater concrete shall comply with ASI 304, Chapter 8. Cementitious content shall not be less than 390 kg per meter cube. Here it's say 390 gram is minimum because it is underwater concrete, sorry. Water cementitious ratio must not exceed 0.4. Fine aggregate contents of 45 to 55%. Fine aggregate contents of 45 to 55% by volume of total aggregate and air contents of up to approximately 5% are generally specified. Fine aggregate contents of 45 to 55% by volume of total aggregate, that's fine aggregate, and air contents of up to approximately 5% are generally specified. Concrete shall be more cohesive and less prone to washout of cement or fines from concrete during placement. Anti-wash admixture or alternative concrete mix be used for underwater concrete. Trial placement shall be conducted to verify that concrete proportion with anti-wash out admixture can maintain adequate slump life and can flow for required distance. Concrete mixture shall be designed of high slump not less than 150 mm, allowing proper free fall with excellent homogeneity. Use of air entering mixture shall be evaluated as it increases workability. When concrete mixture requires slump of greater than 230 mm, it shall be designed as self-compacted concrete. Increase in slump shall be made using proper admixture. Concrete slump shall have adequate retention using approved type of retarder and shall be submitted in design mix. Increase in workability shall not permit any decrease in specified design strength. Concrete shall be placed in one continuous operation. Final selection of concrete mixture shall be based on test placements made underwater in a placement box or in a pit that can be dewatered. After placement, test specific placements shall be examined for concrete surface. Test placement shall be examined for concrete surface flatness, amount of lathens present, quality of concrete at extreme flow distance of test, and flow around embedded items if appropriate. Shotcrete. Shotcrete. Classification of shotcreting shall be in accordance to process used, that's wet mix or dry mix, and size of aggregate used. Material shall be according to QCS except for aggregate where gradations shall be per ACI 506R and 5062R. Steel and synthetic fiber shall be used. Steel and synthetic fiber shall be used to reduce propagation of cracks. Fiber shall be per manufacturer supplier data sheet and conform to ASTM A820 for steel fibers and ASTM C116 for synthetic fiber. Nozzle operator should be certified, refer to ACI CP60, and have completed at least one similar application as a nozzle operator on a similar project. Nozzle operator should also be able to demonstrate by test an ability to satisfactorily perform required duties and to apply shotcrete as required by specifications. Before shotcreting, surface shall be prepared and maintained before and during shotcrete application. Surface preparation shall conform to ACI 506R Chapter 5. Cementitious content shall not be less than 360 kg per meter cube. Cementitious content shall not be less than 360 kg per meter cube. Where wet mix is applied, slump shall be in range of 40 to 80 mm. Normal testing age for compressive strength are 7 and 28 days. However, shorter period may be required for particular application or conditions as directed by engineer. Testing shall be on daily production or every 30 meter cube, whichever is greater. Sampling and testing, however, should be varied according to size and complexity of project. Sampling should be done in accordance with ASTM-C 1385. Making extra cylinders or panels shall be at request of engineer if testing results vary. Testing for water